Hi, everyone. Chris Tanguanan speaking, as I will be presenting along with my fellow teammates, Victoria Ramirez, Edward Torres, and Ariel Lauper. Today, we're presenting DynamiCode, a web-based learning platform designed to help users prepare for technical interviews. Grounded in the science of spaced repetition for long-term memory retention, DynamiCode aims to simplify the process of studying data structures and algorithms. Our focus is to encourage a habitual study routine and to schedule dynamic review points so that concepts are reinforced and solidified into memory over time. Now, let's talk about the problem. So, the current state for learning DSA is through either taking a course or studying from a fixed list like NeetCode 150, for example. In either route, there's little to no personalization. Learners aren't provided with individualized review points for reinforcement. Mostly, it just comes across as a suggestion. So, even with NeetCode's 150 problems for learning DSA, it still sounds daunting to tackle, doesn't it? Our project seeks to change that. DynamiCode will be built to narrow a user's focus. Consider it almost like a sliding window, gradually expanding as our users progress. Through doing this, we can help users form daily study habits, while our system will dynamically schedule reviews based on individuals' performance, optimizing in both time efficiency and memory retention.
We will now discuss our approach. Collectively, we have decided to utilize the Agile process. This allows us to maintain flexibility and speed in development. We have also set a tentative weekly meeting with our advisor and will confirm a regular meeting time to receive guidance and insight into how to best approach each task. To stay in sync as a team, we have established 2 regular team meetings per week, and in addition, we have been communicating asynchronously through Discord as needed for ongoing collaboration throughout the week. Finally, in order to thoroughly plan the project, diagrams such as ER and system environment diagrams have been created to better visualize how the system should be built.
In this section, we will discuss the key risks along with the main dependencies. Our project depends on 3 key components. First is the backend setup. This provides the foundation for storing user data and managing problem sets. Next is the spaced repetition engine. This powers the adaptive learning experience and ensures that we collect valid data from our test users. Finally is user authentication using Google SSO. This will enable our test users to log in securely and verify that our spaced repetition engine accurately tracks their progress. Together, these dependencies ensure our platforms function smoothly and can deliver meaningful results during testing. There are a few major risks that could impact our project goals. First is the complexity of the algorithm. Building and tuning the spaced repetition engine to be effective for different learning styles may take more time than we have. Second is user adoption. While our concept is strong, there are many existing learning platforms, so we will need to test early and refine our design based on feedback. Last are legal and privacy concerns. We must ensure that all problem sets are properly licensed and that user data is protected under regulations like the General Data Protection Regulation and the California Consumer Privacy Act. By identifying these risks early, we can take proactive steps to reduce their impact.
In this section, we'll define the final deliverables of the project. The final deliverable of the project is to have the DynamiCode web application fully developed and accessible for use. Users will be able to create an account, log in, and practice data structures and algorithms through interactive problem sets. The platform includes a clean user interface, a built-in problem-solving whiteboard, and progress tracking as part of the core features. Before launch, we'll make sure to get client or advisor approval so the platform meets user expectations and educational goals. In this section, we'll discuss the current state of the project. So, what have we achieved so far? And this diagram represents our project's overall workflow and current standing. The blue boxes show that we have completed so far, which includes the database schema, the SQL database, and the low-fidelity wireframe for the front end. These mark our foundation on both backend and front-end sides. The solid lines show our next phase and how the different microservices connect to ensure asynchronous communication, meaning that each service can operate independently while still staying synchronized. The dashed lines represent the following phase of work, which includes building REST API controllers, integrating services, and setting up both unit and end-to-end testing. Overall, we have completed the initial setup and design work and are now moving into the stage where we connect everything together and begin full integration and testing. In this section, we'll outline key milestones to show our project's overall progress and flow. This slide introduces the full project timeline from idea to release. We begin with planning and requirements where we define goals, user needs, and scope. Next, we handle design, which includes low-fidelity wireframes and the evolving data model. After that, we prepare the environment and repositories so everyone can run the project the same way. We then move into backend development where we create services, data access, and APIs. In parallel, we build the front end with the core screens and interactions. Once both sides are in place, we integrate authentication and connect to the space repetition engine to the database and user flows. The next stage is quality work. We write and run tests, refine usability, review accessibility, and improve performance and security. Finally, we deploy to a hosted environment, gather feedback from testers and our advisor, and make final adjustments before the public release. This timeline shows how each stage builds on the previous one, so by the end of the project, we deliver a stable and usable version of DynamiCode. In this section, we'll outline each team member roles and responsibilities. Up to this point, we have all contributed equally to the planning work and to the initial database schema. Going forward, we will work in pairs on the same task so each person has support and quick help when issues come up. Partners will rotate across areas to keep the workload balanced and to give everyone experience on both the front end and back end. The main areas of work are ER design, the database implementation, UI and UX design, front end development, and back end development. Responsibilities will rotate across these components. At the end of the project, all team members will take part in integration and testing so the entire team is familiar with the full system and can troubleshoot together. Together, our goal is to deliver a complete functional system that reflects teamwork, shared learning, and balanced collaboration. Thank you.